fixed.
Shit.
Smart.
Why don't you just dip after that?
Oh, yeah, record your stuff.
Luke, or you just go on a field trip and have fun with
Yeah.
your friends. Okay, it would be
You don't know what
nice.
fun is.
But they made us, they didn't make us do with the people we knew. They separated us into groups, until like 12, like 1 o'clock.
Uh-huh.
We were with like
Lucas
other,
heard.
we were eating with people from our
Lucas
school and like
Alexander.
Richardson.
No
Xavier,
way, your
Island.
middle name is Alexander.
And unless you knew them, then you would drink
Okay,
team building
what-
exercises with them
what were
because
they
they're going
cooking?
to the same colleges.
What were they
So like
cooking?
you didn't know people.
That's cool.
Probably right.
Sure.
So I guess if it's with like a college,
It
it's
was,
kind of
it
a,
was all right. I mean, it was like, they made us do like name games.
to know each other's names going in, that's nice.
Well, was it just for seniors?
I think it was seniors year.
I feel like most seniors should know their names, right?
Well, like, no, like other schools.
It's like from other,
oh,
yeah,
oh,
RSC schools, but they're going to the same college school.
Oh,
You know?
so they paired them up? That's kind of cool.
Yeah.
I felt shit.
Oh, yeah.
Did you enjoy the people you're paired
She
up
called
with?
you up,
Do you know where
I'm
you're,
sorry.
or well, I'm assuming you know where you're going. Where are you going?
I think Dallas College.
He's gonna take that. Man.
It's free. Can't beat free.
2 years and then transfer. Yes.
Where are you
Nice.
transferring to?
All right.
Probably UTD for the literature program.
All right, are we ready to learn and review all the things? Yes. Okay, so position, the derivative of position is velocity. Yes. If your particle is at rest, your velocity should equal 0. Okay, but remember that if your velocity is not 0, then the sign will determine which way you're going. So if it'll determine your direction. Okay, so if your velocity is positive, you're going up or to the right. Negative means down or to the left. Okay, then if your velocity changes, when the sign of velocity changes, there are critical numbers / mins and maxes. And then the last two things here, if you integrate velocity, you get the change in position. And then we actually learned a word for that. Do you remember it? Starts with a D. No. Displacement.
True.
Okay, and displacement, how far an object is displaced is its like final position compared to where it started. Okay, then an integral absolute value velocity is distance traveled. Okay, so the big difference between those is that distance traveled, you always count anywhere you went as positive, versus for displacement, you would count forward as positive, backwards as negative. Okay. All right, so let's take a look at the first question here. It says a particle is moving on the x-axis, they give us velocity. Okay, then it says if the particle is at position 2 at time 0, what is the position of the particle at time 1? Okay, so they're asking us to go to position and we have velocity. Is that a derivative or an antiderivative? PVA. We have velocity and we're wanting position.
Oh, sorry.
Antiderivative, that's right, because I'm going backwards. So then I would say, okay, well then position is going to be the integral of velocity, which is 3t squared plus 6t. Okay, now let's actually take that integral. So 3t squared, what's the antiderivative? Up the power, then divide. T to the third. And then what about the 6t? Plus. Okay, and then what did they give us to find the c?
Endpoints. Non-endpoints.
Not endpoints.
X equals 2, t equals 0, t equals 1.
Okay, yes. So the position is going to be 2 at time 0, means the answer is 2 when I plug in 0. Does that make sense? So you're going to use that information to find your c. So then if that's 0 squared plus 0 squared plus c, then c equals what?
2.
C is 2. And then I can come back up here to my equation. Okay, I can just cross out the c and put a 2. All right, so we have our position equation. Okay, then what are we asked to find position for? What time? Okay, time 1. So then the last step would be just to take my equation and plug a 1 in to find the position. So it says position at t equals 1 would be 1 cubed plus 3 times 1 squared plus 2. So that'd be 1 plus 3 is 4, plus 1, 2 more is 6. Make sense on that?
Sure.
Okay. We'll come back to the next one. Go ahead and skip. What'd you say? That doesn't seem good.
I'm Barney.
Wow. I'm tempted to sing the Barney song, but I'll avoid. Okay, look at the next one. Okay, we have a velocity equation. And it's asking us how far the particle traveled. Are we doing a derivative or an antiderivative? Antiderivative, and what did they give us this time?
Velocity.
They gave us velocity, but they're giving us endpoints, right? So your distance traveled will be the integral between those times. So it'll be the integral of 3t to the half, and then plus 5t to the 3/2 dt. And then where are we taking the distance traveled between what times? 0 and 4. All right, let's add 1. What's a half plus 1? 3/2. And then how do I divide by 3/2 in the front?
You take the reciprocal. and multiply.
The reciprocal. So if I want to divide by this new power, I'm really going to times by 2/3. Okay, then for my next term. And actually, can I just cross these 3, John? Is that fine? Because one's on top, one's on bottom. So really that's just 2. Okay, then here I have a t to the 3/2. What's 3/2 plus 1? Or 2/2 if you like that better. 5/2. And then to divide by 5/2, I have to times by 2/5. And then what will happen with our 5s there? Let's cross those out. Now, normally you'd have a plus c. Why don't I need a c this time? Okay, grab the sheet right there. Because we have endpoints. So we'll have 2t, 3/2 means cubed and square rooted. And then 2t to the 5, and then the half means square rooted. We're just on the second page. It's okay. All right, let's plug in 0 first because it'll be easier. What is the square root of 0? And then cube it.
0.
And then times it by 2. Still 0. What about this one?
Probably still 0.
Yep, then plus 2 zeros, you get 0. Okay, now let's do 4. So I have 2 times the square root of 4 cubed plus 2 times the square root of 4 to the 5th. And then remember, it's pretty much always going to be easier to do the root first and then the power second. So the square root of 4 is,
2.
and then what's 2 cubed?
8.
So that's 2 times 8 will be 16. Plus square root of 4 here is 2, and we need it to the 5th power.
Which is 32.
32, good. And then 16 plus 32 will be 48, good. And then once I get those 2 final answers, remember we're subtracting. So 48 minus 0 would give you,
0.
did we do it?
You forgot to multiply the 32 by 2.
Ah, thank you. Thank you very much. So 2 times 32 means that'll actually be a 64. Good job. And then 64 plus 16, oh good, now that's an 80. And then 80 minus 0 will give you answer D. Good save, Kat. Okay, questions on that? All right, go down to the next one. So after you have position, you take the derivative, you get velocity, you take the derivative again, you get,
Derivative.
yep. And the derivative of velocity is
Acceleration.
acceleration. So acceleration tells you two things. It does tell you concavity on the position graph, but you almost never use it for that. Okay, specifically, normally you would say acceleration tells us whether velocity is increasing or decreasing. And if you integrate acceleration, it tells you how much the velocity changed. So acceleration tells you increasing or decreasing on velocity, and it tells you how much the velocity changed if you integrate it. So let's take a look at the next one. It says, for time 0, the velocity of the particle traveling along the axis is given by this. Okay, then it says, at what values is the acceleration equal to 0? Is that a derivative or an antiderivative? You have velocity, you want acceleration.
Derivative.
That's a derivative. And pretty much half the test will be you're taking a derivative, half the test you're taking an integral. Okay, so when I take the derivative of this, what rule will we need? We just covered it yesterday in class.
Product rule.
It will be product rule, good. So my u is going to be t minus 5. My v is going to be t minus 2 squared. And then we're going to take each of those derivatives. What's the derivative of t minus 5? 1. Because remember, t and x are the same. Okay, then for your v prime, you're going to have to do chain rule because it's a bunch of stuff squared. So my 2 will come down to the front. What will the new power be on the t minus 2? Now it'll just be to the 1, which you don't have to write. Okay, but then you have to still times by the derivative of the middle, which is times what? 1, which again, you don't really need, but you can write it if you want to. So the 2 comes down to the front, the core stays the same, but you drop the power, and then you do an extra times 1 for chain rule. All right, so let's write our acceleration. A of t equals this plus that. So it'll be 1 times t minus 2 squared plus, and then here I have a t minus 5 times a 2, and then another t minus 2. Okay. Now my plus 1 here, I'm just kind of leaving that off because for what? We don't really need it. Okay, from there, we want acceleration to equal 0. So what term, we haven't done this actually in a really long time. What term can I factor out of both of those? They have to both have it for you to be able to pull it out as a GCF. Not just a t minus 2. So my t minus 2 will come out to the front. And then I'm going to put a big bracket and write anything that's left over. So the first term was originally a t minus 2 squared. So once I pull a t minus 2 out, what's going to stay here? An extra t minus 2, very good. Plus. And then from the second term, I took out the t minus 2, but what's left over? And the 2. So what I would do if I were you is instead of putting these in there separately, let's just distribute. So the 2 times the t makes that a 2t, and then the 2 minus 5 makes that a minus 10. Okay. Then from there, what can we factor out? Or what can we combine like terms with in there? So what is t and 2t? How many? 1? Oh, wait, hold on. 2t and t would make 3t, right? Because you're adding these. And then the -2 and the -10, that would give you -12. All right, we're almost there, but the 3t minus 12 has a GCF now. What can we take out?
3.
3. So then you'd have t minus 2 times 3. What would be left over in there now? From this
3t. Oh, just t minus 4.
4. And so then what would my solutions be if I have a t minus 2 parentheses and a t minus 4?
2 and 4.
Good. Should be C. Questions on that? Okay, then it looks like the next question is identical. which is probably a mistake. So, turn the page. Next one we're going to work through is, this is actually more of a, let's do the true response a little bit later. Let's skip to the next multiple choice page. Okay, let's do that top one. So it says a particle moves along the x-axis with its position given by, then it says, when is the particle at rest? Okay, so if the particle is at rest, what do I need to find and what am I gonna do with it?
Position.
Okay, I have position.
Oh, and just set it equal to 0.
At rest isn't position equal to 0, it's what?
Time equals 0.
Velocity equals 0. And how do I go from position to velocity? Take the derivative, very good. So when I take the derivative of that position, what am I gonna need? Product rule, very good. So to go from position to velocity, I know I'm gonna take the derivative and then I'm gonna set that equal to 0. That's the game plan. So for my derivative, I'm gonna need product rule. My u is gonna be a t minus a. My v is gonna be a t minus b. And then what is my u prime? The derivative of t minus a.
1.
1. What happens to the a though? What does it say they are? Constants.
So
And
1
constants, they go to
Just
0, right? Because when you take the derivative of a constant, it just falls off. So that's why this is just a 1. What about your v prime? The t will go to a
so 1.
1 and your constant will fall off. Okay, then from there, we're doing this plus that. So my velocity will be t minus a plus t minus b. And then I wanted that to equal what for my velocity? 0. Okay, now the parentheses are kind of there at first, but since it's just a 1 on the outside of both of those, because you're just multiplying each one by 1, I would say let's just drop them and do t minus a and t minus b. Okay, kind of weird, but what can I do? Think about solving equations and
T
stuff like
squared.
that. Not t squared, but close. I can
2t.
combine them, 2t. Yes, so t and t make 2t. Then I have a minus a and a minus b. Where can I send those? Opposite side, and when they're moved across, they'll now be what? Now they'll be positive a and b. And then what will I do next? 2, you'll divide by 2. Very good. So it'd be a plus b over 2. All right. Let's take a look at the next one. It says the position of the particle is negative 5t squared. I'm going to write that down. X of t is negative 5t squared. And then it asks you to find the average velocity for 0 less than or equal to x less than or equal to 3. Okay. There are 2 ways you can find velocity. If you take the derivative and plug it in, that's instantaneous rate of change. That's the instant velocity. But if you want the velocity over an interval, that's AROC. Okay, so if I want average velocity, that's the average rate of change or the average slope of position, then you're doing the formula, which is f of b. We'll write it down here, minus f of a over b minus a. And keep in mind that the difference is if it was an IROC, which I'm going to put right here, that would be f prime at the number that they want. This is at 1 instant versus this is over an interval from A to B. So that's like a pretty good way to tell which one you're doing. You can only take the derivative at a specific point, okay, versus it would be an average rate of change if it's over it. All right, so let's set up our formula. It would be the position at 3 minus the position at 0 over 3 minus 0. Okay, also notice this was on the mock exam. If it asks for the average rate of change, you can't call these F of A and F of B because there's no F. There's a position, so we would use X. Okay, then from there, how will I know X of 3? Uh-huh, to the position, right? So if I want the position at 3, what's 3 squared? Times -5?
-45.
-45. Next, we're plugging in a 0. What's 0 squared?
0.
Times 5 is still 0. And then we're dividing that by 3 minus 0 is 3. -45 divided by 3, what do we get?
-18.
-15, good job. All right. One more multiple choice, then we'll work through a free response. Okay, I want you to read through that and tell me what you think you can kind of find to start with.
Take a derivative.
Okay, derivative.
Velocity and acceleration.
Okay, so let's see if that is right. So it tells us that our particle has a constant acceleration of 3. Is their acceleration changing? No, it says it's constantly 3. So I'm going to put acceleration at any time is 3. Okay, let's read the next line. It says the velocity is 10 meters per second at time 2. The velocity is 10 meters per second at time 2. Okay, so let's think about that real quick. Then it says, how far does the particle travel during the time interval when its velocity increases from 4 meters per second to 10 meters per second? They gave us acceleration, but they're asking us questions about velocity. How do we go from acceleration to velocity? Is it a derivative or an antiderivative? That's an anti. PVA. If they give me acceleration is 3 always, then I'm going to have to do an antiderivative to go back to velocity. So integral on both sides. What's the integral of acceleration called? Velocity. What's the integral of 3 by itself?
3t.
3t plus
C.
c. And then what am I going to use to find the c?
Plug in 2.
The 2 and the 10. That's why they gave us that, is that that'll help me find what this constant is. So at time 2, the answer is 10. Then 3 times 2 gives us 6. And then subtract my 6 across, what's your c going to be?
-28.
Oh, what?
Huh?
Minus 6?
So you plugged in 10.
Oh, no, backwards. 10 is the answer, and then you're plugging in 2 for the time. Yeah, so your C should just be 4. Okay, so now we have a corrected velocity equation. Okay, velocity is 3t plus 4. Okay, now let's read the last part of this. It says, how far does the particle travel during the time when its velocity increases from 4 to 10 meters per second? Are those times? No, those are what? Those are velocities. So how am I going to know the times? I'm going to have to take both of those velocities and set them equal to this. Does that make sense? Kind of weird, but you have to almost like think backwards. They're not telling you to integrate from 4 to 10. They're telling you the velocities. You're going to have to go back and find the times. So first, let's start with 4. If I let my velocity equal 4, what time would that be? What would I do first? Okay. And what's 4 minus 4? So then 3t needs to be 0, which means t needs to be 0. If I divide by 3, that's not going to change. Okay, so it said from the time interval when the velocity is 4, and then it's going to go to 10. So my first time is 0. What's my second velocity going to equal? 10. So my velocity is 3t plus 4. and it needs to equal 10. Okay, what do I do first? Subtracts the 4. 10 minus 4 gives us 6, which means divide by 3. My second time is 2. So really, I want to know how far the particle traveled from 0 seconds to 2 seconds. Does that make sense? And then how do you know how far the particle traveled? What do you do with velocity?
It accelerated 3 meters per second, so 6 meters in 2 seconds.
That's for acceleration. For distance traveled,
Oh, totally that.
nope, we're doing another integral, right? But the 0 and the 2 are going to be our endpoints. So remember, back on your very first page here, okay, we wrote somewhere, okay, that if you want to know how far the change in position is, you need to integrate velocity. Okay, that's what velocity tells you when you integrate it. So acceleration tells you how much velocity changed, velocity tells you how much position changed. Okay, so now let's go back to our question. So we know it's from 0 to 2, but we need to integrate velocity, which is 3t plus 4 from 0 to 2. What's the antiderivative of 3t?
2/3 t squared.
Close. 3/2 t squared, right? Because you up the power first and then divide.
Bro, what the
I don't know what that was. Okay, then my plus 4 is gonna go to a what? 14. And then I don't need a c because I have what?
The thingies.
The endpoints. Okay, but if you put the plus c, it's not wrong. Okay, then we're plugging in a 2. What's 2 squared here? 4 times 3. 12 divided by 2. 6 plus. Plug it in here. 4 times 2 is 8. And then what's 6 plus 8? 14 for the top. What will the bottom number be? 0. Because you'd have basically 0 plus 0. Then with those two numbers, we subtract. Make sense?
Yes.
Okay, that one kind of took you to some weird things to have to do, but I would just say go one thing at a time. And if you read one like that initially and you don't know where to start, skip it. There's 45 questions. Pick one you know how to do first. Okay, next one we're gonna do is the graph of V right here. Okay, so take a look. First thing it asks you to do is to find the time and position of the particle when it's farthest to the left. So my first question is, if I want it farthest to the left, are they asking you for a min or a max? That's a min, very good. Now, not only is it a min, but it's an absolute min because we have endpoints, which means anytime it's absolute, you're gonna have to do a candidate's chart. Okay, so first question, what are we looking at the graph of? V, which is velocity. Where will I find the points where my particle then was at rest? The zeros, very good. And there are 3 of them. There's one here, here, and here. So my particle is at rest at 0, 3, and 5. Now, out of those x-intercepts, which of those is going to be, out of those x-intercepts, which one will be a min? Will it be 3 or 5? Think about the direction of the sign change.
5.
Yeah.
3.
Negative. Negative to positive is a min. And if you think about a negative slope to a positive slope, that's a min, versus at 5, a positive to a negative outlines a max, yeah?
5 is bigger than 3.
That is true, but that's not why. Okay, so I know that I have one min and one max. The problem is I don't know if that min is the overall min. So you're gonna set up a chart here. Remember, the 2 things that go in your chart are the endpoints and the critical numbers that we just found. So what are my endpoints from where to where?
0 to 5. Yeah.
0
To
till 6. And then what were my two critical numbers? 3 and 5. Okay, now the initial position, they have to give it to you somewhere. Okay, but it won't be in the graph because what's in the graph? Velocity. So look in the giant paragraph. When does it give you the position at 0?
X is -2.
Very good, right here. Okay, at time 0, the particle is at -2, means that's the starting position. And they have to give you that. Now, from 0 to 3, how am I going to know how far the particle moved? What am I going to calculate here? Area, good. And since it's not a perfect geometric shape, we're looking back to the paragraph. What does it tell us about the areas? The areas of the regions bounded by the t-axis in the graph on 0 to 3, 3 to 5, and 5 to 6 are 8, 3, and 2. So
So
this
8.
one's 8, 3, and 2. Now, if the particle started at a position of -2, and then it traveled 8 units below the x-axis, where would its new position be? -10 is correct. Very good. So I do -8, that puts me at -10. Okay, then what happens between 3 seconds and 5 seconds? How much do we accumulate? How much area? +3, which means that my -10 is going to turn into a what? -7. And then the last second, I go backwards, how many? 2. Then that would put me back at -9. So then what is my absolute minimum position when I'm farthest to the left on the chart?
3.
Good, and make sure you write it in the right order. You would say the farthest to the left is -10, and it occurs at time 3. Does that make sense? Farthest to the left is -10, it occurs at time 3. Okay, and if you accurately label your chart here, okay, so time and then position, okay, then you don't have to write like a big long sentence, just make sure you label stuff. Okay, look at part B. How many time values from 0 to 6 is the particle at -8? Okay, how would we answer that question? Okay, so first question, if I go from -2 to -10, am I gonna hit -8 in the middle?
Yeah.
Then that's at least one time. Then from -10, where do I go? Do I hit it again? That's 2. What about from -10 back up to -9?
You hit it again.
You hit it again, so then how many times
At
total?
least 3.
At least 3 times. Okay. So at least 3 times. And then I would basically give some sort of explanation related to that theorem is called
Vermont's, no.
Intermittent.
IVT.
Intermittent value.
And remember, the I stands for intermediate, meaning between. So you would say at least 3 times, -8 is between the positions on all 3 intervals. And then if it were me taking the AP test, I would list them. So 0 to 3 and 3 to 5 and 5 to 6. And because it's between the positions at each of those intervals. Okay, and then you might even say too, like IVT guarantees this just to name the theorem, but usually they won't take off points if you don't name it. Okay, next question says from 2 to 3, is the speed increasing or decreasing? Do we remember how you know if speed is increasing or decreasing? Same or opposite? Which one is speeding up if they're the same? And then slowing down would be opposite. So from 2 to 3, go back and look at your graph. What is this a graph of? Okay, then what feature would acceleration be? So velocity are the y values, because this is a velocity graph. What would acceleration be compared to velocity?
No, we just said what?
Okay, how do I get from velocity to acceleration? I take a
Derivative.
derivative, and what's a derivative in a graph? It's a slope. Does that make sense?
Oh,
So
oh,
acceleration is gonna be the slopes on the V of t graph. Okay, so V is your Y value. That would be like above or below. Am I in the positives or the negatives? And then acceleration is the slope of the graph on that interval. What interval am I looking at? 2 to 3. So from 2 to 3, I'm here in this part right here. Am I above or below the x-axis?
oh.
I'm below. That means my velocity is what?
Negative.
Negative, because I'm in the negatives. I'm below the x-axis. Okay, but then what's my slope? Which means my acceleration is positive. So then overall my speed is slowing down. Very good. So let's write that out. We would say speed is decreasing because you're below the x-axis, but you have a positive slope. And so those would count as opposite sides. Okay, so we'll write that out. Speed is decreasing because velocity is less than 0. And then I would even put below x-axis, just to make sure that you're being super clear. Okay, below the x-axis, but acceleration is positive. And then I'd put because velocity slope is positive. So your acceleration is the slope, but your velocity is below. They end up being opposites. Okay, then last question here for part E. It says, during what time intervals is the acceleration negative? What feature is acceleration on this graph? Slope. And where is the acceleration or slope negative? On what intervals?
4 to 6.
4 to 6, and there's one more.
0 to 1.
0 to 1. Very good. Okay, the other thing that they did not ask, but a lot of times they will ask, is at what points does the particle change direction? And what values would we list for that? Remember, change direction would be all of the x-intercepts where it passes through. So go ahead.
2 to 4. Or
It'd be a specific moment that it changes. So everything down here, it was traveling to the left until when? 3. And then what happened? It was traveling to the right. And then when did it switch again?
5.
5. So your at rest points here would also be basically your direction changes with the exception of 0, because that's like the beginning. You know what I mean?
Yeah.
Okay, but it did say to justify down here. So I would put because acceleration is the slope on the velocity graph and it's positive. Something like that. Okay, but you want to connect your acceleration back to the graph that they gave you of velocity. Okay. All right, I think we have time for one more. I don't think we really have time for a calculator question. So let's do the no calculator one. I think there was one. Yeah, it's right here. Okay, so it says, in which direction, up or down, is the particle moving at time root 3 pi over 2? Okay, they gave us velocity. So let's plug that in and see how it comes out, but sadly, no calculator. So we can do it. So my time is root 3 pi over 2. And I'm plugging it in right here. So I have a t in the front. I'll put a root 3 pi over 2 there. And then I have a sine of t squared, which is root 3 pi over 2 squared. Okay. Now, first question, what's going to happen when you have a root 3 over 2 pi and then you square it? It's just going to be 3 pi over 2, and this square root and the square will cross out, yeah? So I just have the random root 3 pi over 2 in the front, and then I want the sign of 3 pi halves. Okay, now on your finger, on your hand, which finger is the pi halves finger if you do hand trade? 0, pi 6, pi fourths, pi thirds, pi halves. This one. How many of your fingers are down?
4.
All 4, so it's root 4 over 2, which is 2 over 2, which is 1, but I'm not at pi halves, I'm at 3 pi halves would be
3.
-1. Okay, now let me show you why, in case you're confused. So remember, it's 1 pi across the top. And then 3 pi halves would be like 1.5, which puts you down here at the bottom. Okay, but then think about it, if you do all students take calculus, what are the signs in the bottom half of the circle? Are they positive or negative? They're pretty much all negative. So if sign is negative here and it's negative here, then it's gonna be negative at 3 pi halves in the middle. So the number is 1, it just happens to be -1. Okay, now, why does it matter that the velocity came out negative? What does that tell us about direction? Well, it says up or down, so we'll pick down, but a lot of times it is right left. So we'll put therefore particle traveling down, travels down, since velocity is negative, something like that. Okay. Then next part asks you to find acceleration. If I have velocity and I want acceleration, what are we doing? Derivative, what rule are we gonna need? Okay, it will have chain rule and what else? Product rule, very good. The reason, that's okay, the reason that you know is that you have sine multiplied by an extra t. So that's a product rule. Okay, and then the chain rule will come in while we're doing product rule because it's not sine x, what is it? Sine x squared. So anytime that's not just a regular x in the middle, you're doing product rule and chain rule. So let's do our u first. So our u is just the t, what's u prime? 1, good job. Okay, then my v is gonna be the sine of t squared. How do I take the derivative of sine t squared?
Cosine 2 squared, t squared times 2t.
Perfect. Okay, and then I usually will put the 2t in the front. Okay, but that's there because of chain rule. So sine goes to cosine, you keep your t squared the same. And then you'll multiply by a 2t either in the back or the front. Okay, so then let's write our velocity equals. And then it says t times 2t cosine t squared plus 1 times sine t squared would basically stay the same. And then notice that it says at any time. Oh, go ahead. I did mean that, thank you. Okay, this was velocity, then the derivative should be acceleration. Okay, now you could simplify the t and the 2t and make it a t squared if you wanted, but I wouldn't. Okay, if it says at any time, once you've taken the derivative, I would just leave it. Okay, then last part of this, we'll do C and D. It looks like we're just setting them up. You need a calculator to actually do it. How would I find position at time 2, given the position is 6 at time 1? This is a little bit tricky, but I want you to think about it. How would I know how far it moved from 1 to 2 seconds? What would I have to do to velocity? Integrate, very good. So start with that. I would have to integrate from 1 to 2 on velocity. That's gonna tell me how far it moved. Okay, but how far it moved is in position. How far it moved from where? What was the position at 1? 6. So you would basically have to think about, I was already at 6, and then this is how much I moved from there. So let's say that this comes out to 3 units, then I'd say, oh, 3 plus 6 comes out to be 9. Does that make sense? So your position at 2 will be whatever your position was at 1 plus how far it moved between those times. Okay. Now, what is the difference between what we just did here and distance traveled? Can an integral come out to be positive or negative? Can a displacement come out to be positive or negative? You can go forward or backwards. Yes, but for distance traveled, we want to count it all as positive. So instead of integrating velocity, what would we integrate? How would we make sure it's always positive?
Acceleration.
Nope. Go back to right here. Very first page. How do I find distance traveled? What do I do to velocity? Absolute value bars. So displacement tells you how much it moved, but it can be positive or negative. For distance specifically, you have to put bars around it. So you would do the integral from 0 to 4, absolute value bars, velocity. Now, one more question. For position, you care about where it started. For distance traveled, will you get credit for these initial 6 if that's where you started from? Do you get credit for those if you didn't move on that interval that time? No. So your distance traveled, you're not including anything extra because if you didn't do it between 0 and 4 seconds, it doesn't count. So if your starting position is 6, you wouldn't take that into account. You would just say, what's the integral from 0 to 4? Make sure everything counts as positive. Versus for a final position, you would say, okay, where did I start from? Plus, how far did I move? Does that make sense? Those two words sound similar, but they're different. Okay, and then you do those in the calculator. All good? Okay, good job. We went like 3 minutes over, sorry. And then Dika, when I post the video, you want to finish it and I'll sign your packet.